All right, welcome. Today, we are diving into a problem that has been a real headache for developers for decades. You know the one, having to choose between a database that is absolutely rock solid and one that can actually handle massive growth. Well, we're looking at YugabyteDB, a database that basically says, hey, you don't have to choose anymore. It wants to give you everything.
You know, for the longest time, building an application meant you hit this fork in the road. It was a painful choice. Did you need a database that guaranteed every single piece of data was perfect? We're talking financial transactions, stuff you can't get wrong. Or did you need one that could handle millions of users, scaling all over the globe? You could have consistency or you could have scale. But getting both? That was the holy grail.
So, how do we even get into this mess? In this explainer, we're going to start with that classic dilemma. Then, we'll get into the vision that sparked YugabyteDB. We'll peek under the hood at its architecture, see how it manages to pull off the best of both worlds, and finally, we'll talk about why this is such a big deal right now.
Okay, let's set the stage here, because this isn't just some technical problem. It's really a clash of two totally different philosophies about how you should manage data in the first place.
So, on one hand, you've got your traditional SQL databases. Think PostgreSQL. Their big promise is strict consistency, what the pros call ACID compliance. The best way to think about it is a bank transfer. The money is absolutely guaranteed to leave one account and arrive in the other. If any part of that fails, the whole thing is rolled back. It's all or nothing. But trying to scale that kind of guarantee across tons of servers, it's incredibly difficult. Then on the other hand, you have no SQL databases. These were built from the ground up for massive scale. But to get that scale, they often had to compromise on that strict consistency, which, let's be honest, is a total deal breaker for any app where data accuracy is everything.
And it's that exact dilemma that set the stage for something new. A group of engineers who had lived and breathed this problem, day in and day out, decided, you know what, we're going to build a solution from scratch. And listen, we're not talking about just any engineers here. The founders of YugabyteDB came directly from Facebook. These were the folks who were actually building and running the gigantic NoSQL systems that power the social network. So if anyone understood the pain of trying to get consistency at a truly global scale, it was them.
So their journey kicks off in 2016. They were really inspired by Google's work on a database called Spanner, which was kind of the first big proof that combining global scale and strict consistency was actually possible. So they set a super clear goal: take the power and the familiarity of SQL and fuse it with the incredible horizontal scale of NoSQL.
And really, this was the whole mission. It wasn't about making a slightly better NoSQL database or a slightly more scalable SQL one. Nope, they wanted to create a whole new category, a distributed SQL database that just refused to compromise.
So, the big question is, how on earth did they actually pull this off? I mean, the vision is one thing, but the execution is everything. Let's get into the core architecture, the tech that makes YugabyteDB tick.
The magic really starts right here, with something they call DocDB. Think of this as the absolute foundation of the whole system. It's a custom-built storage engine layered on top of a really proven technology called RocksDB. Now, the crucial part is that it stores all data in a flexible document format, and that one design choice is the secret sauce. It's what allows it to speak both SQL and NoSQL from the exact same engine.
Okay, so if you've got your data scattered across servers all over the world, how do you make sure they all agree on what the latest version of that data is? Well, the answer is a consensus protocol called Raft. The easiest way to think about it is like a committee vote. Before any change is made permanent, a majority of the servers have to agree on it. This guarantees that your data is never in some weird, conflicting state, even if one of the servers goes down.
So let's put it all together. When you write data to YugabyteDB, here's what happens. First, the system automatically shards it. That just means it breaks your data into smaller, more manageable pieces and spreads them across the servers. Then, each one of those little pieces is replicated using that Raft protocol we just talked about, so you have multiple safe copies. And finally, the database makes sure that any transaction, even one that touches multiple machines, maintains those super strict, all-or-nothing ACID guarantees.
Okay, so all that clever engineering under the hood leads to one massive benefit for developers, and that is choice, but without the old compromises. You get two different ways to talk to the database, and both are powered by that same powerful distributed core.
And this is where developers really get the best of both worlds. On the one side, you've got YSQL. It speaks fluent PostgreSQL. So if your app needs complex queries, joins, and that ironclad consistency for a relational workload, this is your tool. Then on the other side, you've got YSCQL.
This is inspired by Cassandra, and it's built for pure speed. Perfect for those high-throughput apps where every single millisecond counts. Two totally different needs, one powerful engine underneath.
And honestly, this is the game changer for so many people. Developers don't have to throw away years of experience and learn something completely new. They can keep using the language and tools they already know and love, PostgreSQL, but now they get to attach the superpower of massive, fault-tolerant scaling that used to belong only to the NoSQL world.
Okay, cool tech, right? But why now? Why is this database getting so much attention today? Well, it's because it was fundamentally designed for the world we all live in right now, the era of the cloud.
I mean, just think about the kinds of applications we're all building these days. Global SaaS platforms that need to serve users in Sydney and London with the exact same low latency. Financial systems that simply cannot, under any circumstances, lose a transaction. Internet of Things applications pulling in data from millions of devices. All of these require a database that is spread out geographically, is always available, and is super consistent. And that's the thing. YugabyteDB was born for this modern cloud-native world. It can run on your own servers, in virtual machines, or, and this is crucial, it integrates seamlessly with modern tools like Kubernetes. It's totally at home on any major cloud platform, giving developers the freedom to build wherever and however they want.
And maybe one of the biggest points here is about trust. YugabyteDB is fully open source, and this isn't just a marketing line. It means any developer can see the code, contribute back to it, and adopt it without ever worrying about getting locked into a single company's ecosystem. It's truly built by the community for the community.
So if you take away just one thing from all of this, let it be this. YugabyteDB's real, core innovation is blending that rich, familiar, powerful developer experience of a relational database like Postgres with the planet-scale architecture and resilience of a modern NoSQL system. It is a really powerful combination that looks to finally put an end to those old, painful trade-offs. And that leaves us with a pretty big question for the future. As more and more of our applications become global by default, is this blend of consistency and scale going to become the new standard for how we build them? Something to think about. Thanks for watching.